And let's take a look at number 36. This is another adding and subtracting a rational expression. So review our steps. Adding, subtracting rational expressions with different denominators. Step 1, factor all your denominators. Step 2, figure out the LCD, least common denominator, and rewrite each fraction with that new denominator. Step 3, add or subtract the top parts and put into a single fraction. Step 4, factor the top, factor the bottom, and step 5, cancel if necessary. So let's go through these steps with this problem. And get my pen to work. Hello. There it is. Okay, 36. So we got negative 3 over x squared minus 9 minus 6 over x plus 3. And step 1, factor all your denominators. Well, x plus 3 we can't do anything with, but this one, the x squared minus 9, is a difference of 2 squares. 2 terms of minus between it. And remember the difference of 2 squares, we try to write it as something squared minus something else squared. Now x times x will give you the x squared, and 3 times 3 will give you the 9. And our formula says you take what's inside your first set of parentheses, you add what's in your last, and you take what's inside in your first, and you subtract what's in your last. So that's going to factor as x plus 3 times x minus 3. Step 2, figure out your LCD and rewrite each fraction of the new denominator. LCD is least common denominator, again. Now we look at each factor. Like I'm going to start with the x plus 3. And we're looking for the greatest number of x plus 3's in any single denominator. There's 1 here and there's 1 here. So the greatest number of x plus 3's in any single denominator is 1. Now we are not adding how many there are. We're looking for the greatest in any single denominator. Now the x minus 3, our next factor. I'm looking for the greatest number of x minus 3's in any single denominator. There's 1 here, none here. So the greatest number of x minus 3's will be 1. So that's our LCD. And we're going to rewrite each fraction with that new denominator. Now you have to look at what was added down below. Well, here we had an x plus 3, the x plus 3 is still there. Here we had an x minus 3, the x minus 3 is still there. We didn't change that one at all. Our second fraction, we had an x plus 3, the x plus 3 is still down there. The new thing that we put down below was an x minus 3. So we had to put an x minus 3 up here. Whatever you put down below here, you put up on top. Basically the rule is whatever you multiply by the bottom, you have to multiply by the top. Well, that becomes, the first fraction remains as is, negative 3 over x plus 3 times x minus 3, minus, and then this is distributive property, 6 times x is 6x, 6 times negative 3 is negative 18, over x plus 3, x minus 3. Okay, step 3. Add or subtract top parts and put into a single fraction. Whenever you have a negative out in front of a fraction, it's going to flip the sign of all the terms up on top. So this negative out in front of the second fraction is going to flip the sign of the 6x and the negative 18. So we're going to have negative 3 minus 6x plus 18 over x plus 3, x minus 3. Combine together like terms, put in standard form, so forth. Negative 6x, negative 3 plus 18 gives us positive 15 over x plus 3, x minus 3. Now step 4, factor the top, factor the bottom. You do that in hopes that something will cancel. Well, up on top here is the GCF, and the bottom is already factored. Remember, if your first term is negative, you always factor out a negative. So I'll factor out a negative, and they're both divisible by 3. And that gives us 2x minus 5 over x plus 3, x minus 3. Now, probably, based upon a previous problem I worked, they go ahead and multiply this through, because we see we can't do step 5. Nothing will cancel. So let's see what their answers look like. Yeah, looks like they multiply everything through. That seems backwards. It's like, well, why did we even factor it out then if we're going to multiply it back through? Well, we factored it out to see if we can cancel anything. Well, negative 3 times 2x gives us negative 6x. Negative 3 times negative 5 is a positive 15. Now, these are conjugates, which I'll mention here in a minute, but if we multiply those back through, we're going to get, actually, it's x squared minus 9. I already did it up here. There's no use to go through the steps. When I say they're conjugates, the first and the second are the same, but the sign in the middle is different. And when they're conjugates, all you have to do is multiply the first parts together. X times x is x squared, and the last parts together. 3 times negative 3 gives you a negative 9. So let's see which one this matches. Negative 6x plus 15 over x squared minus 9, which would be b as in Bill. So 36b. Which matches.